crust, and the most widely used non-ferrous metal. We use aluminium a lot. It is actually the most widely used, of course, after all the compounds that contain iron. C'est le plus utilisé après les composés qui contiennent du fer. Okay? We describe the position of aluminium within the periodic table. I told you about the periodic table. I told you guys that the first group in the periodic table was what we call the alkali metals. The second one was the alkaline earth metals. But actually, I think I will tell you about this later when we will answer some questions, okay? I told you that in the periodic table, the elements are categorized according to their atomic number. We gathered the elements and they have been categorized according to their atomic number. We start with hydrogen 1, helium 2, lithium 3, beryllium 4, boron 5, carbon 6, nitrogen 7, and so on, okay, etc. I told you that the elements of the same family, the same group, will share very similar chemical properties. This is because they have valence shell that will be very similar. They will have the same valence shell electron configuration. Ils vont avoir la même configuration électronique, la couche de valence. The period will change, only the period. For example, if you take nitrogen, nitrogen will have an electron configuration of the valence shell of 2. Valence shell 2s2. This is the period 2, which means 2s2. Yes, Hudayfa, 2s2, 2p?
3.
2p3. Thank you, Hudayfa. Well done. 2p3. Hudayfa, you have a plus. 2p2, 2p3. Phosphorus, 3p2, 3p3. Arsenic, 4p2, 4p3. Antimony, Sb is antimony, l'antimoine. 5s2, 5p3. And bismuth will have 6. 6s2, 6p3. The period will change. Sorry? The difference will be the period, only the period, but the electron configuration will stay the same. Sorry, I can see my kid doing something wrong. Give me a minute. Sorry, I saw my kid going to the balcony. You know the meaning of balcony, le balcon, and actually a lot can be expected. A lot can be expected when a kid. Actually, a lot of things can be expected from a kid. Let's go back to the lesson. Okay. Well. Describe the position. I told you about the fact box, guys. Do you remember? The fact box is a table that gathers the basic information, the most important information of an element. It can be the group, the period, the block, the atomic number, the state, the electron configuration, Chem Spider ID. Chem Spider ID. It is a number that allows you to see the structure, the formula, and the structure of a compound on Chem Spider. This number is used to see the structure or the formula of any compound on Chem Spider. You can try. Melting point, boiling point, we will see what it is. The density. What is the density? We will see it later, inshallah. The relative atomic mass. This is the atomic mass that we've been talking about. Key isotopes. We have been talking about the isotopes. In the case of aluminium, we have only one species. A single element, a single species, no other isotopes. The Cass number, I told you about the Cass number. Whenever we discover, we prepare a new compound. When we register this new compound, it is given a number that we call a Cass number. Why do we give it this number? In order to make things easy. Instead of giving, especially for organic compounds, instead of saying 2-dimethyl 5-on 6 don't know, hydroxy, pentan, dian. It is complicated and you can make mistakes. Instead of using the whole name, you can use the CAS number. It is a number that is assigned to a chemical compound when it is registered. C'est un numéro qui est associé à une molécule quand elle est enregistrée. C'est tout. Okay? I told you, this is a vocabulary that is very important. State, c'est état physique en français. Atomic number, c'est numéro atomique. Electron configuration, and we don't say electronic configuration. Electron configuration, c'est configuration électronique. Valence shell, c'est la couche de valence. I told you that in English, it is easier than in French. It is easier than in French. We don't say it is a group A or a group B. We only have to calculate from the beginning. One group 1, 2, 3, 4, 5, and so on, until we finish. Okay? This is what we said last time. We talked about isotopes. Now we have to answer quickly these questions. First question, what is the state of aluminium at room temperature? What is the state of aluminium at room temperature? Guys, what is the state of aluminium at room temperature?
Solid.
It is a solid, of course. It is a solid. Aluminium, we say aluminum or aluminium, is a solid at room temperature. What is the meaning of room temperature? Room temperature means that it is the temperature that exists in a place without heating or cooling. C'est la température qui existe dans une pièce sans chauffer ou refroidir. When I ask you to perform a chemical reaction at room temperature, it means that you are not allowed to cool or heat. Si je vous demande d'effectuer une réaction chimique à température ambiante, vous n'êtes pas autorisé à chauffer ou à refroidir. Okay? Room temperature is called in French la température ambiante. Okay? Second question. Write its electron configuration. I mean aluminium. Right? It's guys, before moving to the second question, who could state of all when they are solids? It is
Zero.
Zero. Yes. When a metal is a solid, its oxidation state is zero. It is the case of copper, iron, aluminium, or any other metal that exists in its solid state. When you have some metals in solution, the oxidation state changes. Sorry. That's why I try to avoid working on Saturday, because on a Saturday my kids are at home and sometimes it's not easy. Okay, let's go back to the oxidation states. When you have a metal in solution, keep in your mind that that metal has an oxidation state number of +1, +2, +3, sometimes even +7. There are some transition metals that have very high oxidation numbers or oxidation states. Okay? Okay. Second question, write its electron configuration. Guys, if you want to write the electron configuration of any element, what would you do? What do you do? Ferme la porte, s'il te plaît. Ferme la porte. Ferme la porte. Sorry. If you want to write an electron configuration, guys, what do you do? How do you do that? What do you do first? I want you to write the electron configuration of aluminium. Guys, are you? Yes, Hamza. What do you do, Hamza? Sorry.
We calculate valence share.
No, before. But are you sure we did not study this?
No.
We did not.
No, we don't.
We did not. Okay. Hamza, before. Guys, and especially Hamza, listen, before finding the valence shell, avant de trouver la couche de valence, comment écrire la configuration électronique depuis le début? how do you write the electron configuration? Of course, you can use the inert gases, so the inert gases. Vous pouvez utiliser les gaz inertes ou les gaz rares. But you can write it from the beginning. For people who cannot use those gases, you can write the electron configuration from the beginning. How do you do that? Comment vous le faites depuis le début? Comment vous le faites?
We calculate the number, total number of electron.
Yes,
And we,
actually, this is aluminium.
We used
and
the
we,
Yes,
and
this
we
is
use
aluminium.
the S or P or D orbitals.
Yes, actually, there is a way, an easy way to remember how to use what orbitals to be used first. Il y a un moyen pour vous souvenir des orbitales à utiliser en premier. We call it in French la règle de Klitschkowski. This is the electron configuration chart. It means it is a rule. It is a way to make things easier for you, okay? It is a way to make things easy or easier for you. We call it in French the Klitschkowski rule. The Klitschkowski rule shows you how to write an electron configuration. Listen to me, guys, for especially students who do not remember how to use it, how to write it. Before writing an electron configuration, you have to write the Klitschkowski chart or the Klitschkowski rule. Always start with the first orbital, which is 1s. After 1s, go back to the line and write 2s and go back to the line and add another orbital, 3s, 3p, 3d. Add another orbital, 4s, 4p, 4d, 4f. And between 4f and 5f, there is nothing that changes except the period, which means that you do not add and you do not remove an orbital. Let me repeat, you write 1s and you add another orbital, 2s, 2p. You add another orbital, 3s, 3p, 3d. You add another orbital, 4s, 4p, 4d, 4f. Between 4 and 5, nothing changes except the period. 5s, 5p, 5d, 5f. And after 5f, when you arrive to 5f, you remove one orbital, which means it will be, you will remove the f. It will be 6s, 6p, 6d, 7, you remove another one, which will be the d, 7s, 7p. And actually, if you want to write 8, you can write 8s. Okay? Okay, guys? And you start writing the arrows, drawing the arrows. Vous commencez à dessiner les arrows, c'est la flèche, arrow. Arrow, okay? You start writing the arrows from the right to the left. 1s from the right to the left, de la droite vers la gauche, la direction de la flèche. 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, and so on, etc. Okay? Tell me, guys. When we want to write the electron configuration, we have to follow the arrows. On doit suivre les flèches, which means that for aluminium, what is the atomic number of aluminium? It is 13 or 26? 27.
13.
13, of course. I told you, be careful. The atomic number is, except for hydrogen, the atomic number is always smaller than the atomic mass. It is 13. Let's write from the beginning. 1s. 1s, the orbital s can hold up to how many electrons? How many electrons can the orbital hold? Hold, c'est contenir. Hold. Contenir. The up, ça veut dire jusqu'à. The orbital s can hold up to 2 electrons. The orbital p can hold up to 6 electrons. The orbital d can hold up to 10 electrons. And the orbital f can hold up to how many?
14.
14. Yes. 14. Yes, you are right. 7 orbitals. It contains 7 small orbitals. And each orbital can hold up to 2 electrons, which means 7 orbitals, 2 electrons, 14 electrons. Thank you. Let's go back to aluminium. Please help me write in the electron configuration. Help me to write the electron configuration. Let's start with 1s. 1s2. We need 11 more electrons. 2s2. We need 9 other orbitals. 9 other electrons, sorry. 2p, I am following the Klitschkowski rule. 1s2, 2s2, 2p6, I need 3 other electrons. 3s2 and 3p1. 1. Did you all understand how I wrote the electron configuration of the aluminium?
Yes.
Yes, miss.
Okay, guys, who could tell me why Krzyzewski or I just started with 1s before the 2s? Why did I start with 2s before the 2p? Why did I start with 2p before the 3s? Why did I do things like this? What is the scientific basis of this order? Quelle est la base scientifique de cet ordre?
La règle de Hooke.
La différence d'énergie de chaque orbital.
Yes. Thank you very much. Who said that? What is your name, miss?
ميليسا مشرق.
Melissa, thank you. Actually, Melissa is right. It is a matter of energy. C'est une question d'énergie. Actually, it is a matter of energy and it is a matter of stability. There is a very close relationship between stability and energy. Il y a une relation très très proche entre la stabilité et l'énergie. I think I told you that last time. Peut-être que je vous l'ai dit, je pense que vous l'avez dit la dernière fois. When there is a lot of energy or a high energy, the stability is weak, is low. Quand il y a beaucoup d'énergie, la stabilité est faible, elle est basse, elle est faible. For example, and of course, when energy is very low, the stability is high. Let me give you an example. I always give the same example. When a kid, for example, my kid, for example, and of course, I think it's the same thing for almost all kids all over the world. Kids have a lot of energy or not? Do they have a lot of energy or not? Kids in general. Usually kids have
Lot of energy.
yes, a lot of energy. They have high energy levels. Are they stable or not? Are they stable sitting on a chair, reading, thinking, dreaming? Is it correct? Is it the reality? Is it the reality?
Yeah.
No, of course not, because they have a lot of energy. They have to run, they have to sing, they want to play. What about the old people? Do they have a lot of energy? They do not. Usually they are tired or sleepy or even resting. Ils sont fatigués, ils ont sommeil ou alors ils se reposent parce qu'ils ont peu d'énergie. Ils sont stables. This is an example, but it is the case in chemistry, it is the case in nature. C'est le cas en chimie, c'est le cas dans la nature. Quand la stabilité est élevée, l'énergie est faible. Quand l'énergie est faible, la stabilité est élevée. Quand l'énergie est importante, la stabilité est faible. Les orbitales sont classées en fonction de leur stabilité. Les plus basses, les orbitales qui ont la plus basse énergie viennent en premier parce que les électrons voudront se mettre dans l'état le plus stable, toujours, toujours, toujours. Keep in your mind that the electrons will always choose the most stable orbitals. Always the most stable levels, the lowest energy levels, the lowest energy orbitals. Always. Les électrons choisiront toujours les niveaux les plus faibles en énergie, les plus stables. OK? Actually, everything in nature looks for stability. Tout dans la nature recherche la stabilité. OK? OK? We wrote the electron configuration of aluminium. Guys, how do we recognize the valence shell? How do we recognize the valence shell? Comment reconnaître la couche de valence? How do you do usually? Comment vous faites d'habitude?
En utilisant les gaz rares.
Okay, no, this is the electron configuration. C'est la configuration électronique. Instead of writing, for example, 1s2, 2s2, 2p6, you write the equivalent, the electron configuration of the inert gas that will correspond to this electron configuration. Vous allez choisir le gaz rare qui aura la configuration électronique qui correspond à celle-là. Pour n'écrire que 2s2, 3p1. No problem. This is for the electron configuration. You can use the inert gases or you can write it from the beginning. Okay? No, I mean, how do you recognize, how do you write, do you determine, comment déterminer, comment reconnaître La couche de valence.
Miss,
In our case, we wrote the
last orbital
Yes?
S.
The last orbital, actually, no, be careful. You have to look at the principal quantum number. Actually, you are, sorry? Tell me,
The total number.
tell me, girls.
The total number of the electron is the atomic number.
Yes, the total number of electrons is the atomic number. But how do you recognize the valence shell? Comment reconnaître la couche de valence? Est-ce que la couche de valence, c'est NS2, 2S2, is it 1S2, 2S2, 2P6, 3S2, 3P1? Is this the valence shell?
No.
No, just the last with the big number.
Yes, with the highest, avec le nombre, the highest number of the principal quantum number. The principal quantum number, please write it on your copybooks. Le nombre quantique principal. The principal quantum number n, when you have to look at the principal quantum number n. The principal quantum number n, the highest value, la valeur la plus élevée, the highest value will give you the valence shell. For example, one is the principal quantum number for the orbital s. 2s2p, 2, no, it's not the highest. 3, yes, it's the highest, which means that starting from 3s2, you start the valence shell. From 3s2 starts the valence shell. La couche de valence commence avec le nombre, la valeur la plus élevée du nombre quantique principal n. 3, 1 c'est faible, 2 c'est 3 c'est le plus élevé. Et bien à partir de 3s2 vous avez la couche de valence. Okay, guys. The value of the principal quantum number shows you the group, the period, or the block. What does it give you? What does it indicate?
Period.
What does it indicate?
Period.
Thank you. It is very easy. The value, it is very easy. The value of the principal quantum number gives you the period of the element. If the highest value of the principal quantum number is 2, it is the second period. If it is 5, it is the fifth period. In the case of aluminium, what is the period? To what period does aluminium belong? Does aluminium belong to? What period? The third period. The troisième, third period. Yes, thank you. Guys, what about the group? How do we do to know the group?
13.
In French, because in English it's easy, but what about French? It's quite complicated, or more complicated at least. How do we do? How do we do? It is very,
It's 3.
yes.
A.
Yes, thank you. How did you know that, Miss?
The leçon.
Who was speaking?
Melissa.
Yes. Yes.
Quand on a les
Actually,
orbitales S,
you
c'est leçon.
Yes, thank you. This is very, very important. Guys, listen to me carefully. Listen to me carefully. Especially in French, because you're studying in French, you will write those things in French. Comme vous étudiez en français, vous allez devoir les écrire en français. And it is more complicated in French. C'est plus compliqué en français, which means that I'm going to teach you how to find them in French. Je vais vous apprendre comment les trouver en français. Listen to me, guys. When you have two orbitals in the valence shell, when you have, a single orbital, which is the orbital s. For example, you write the electron configuration of an element, and you find that within the valence shell, you will have only, for example, 2s1 or 3s1. You have only the orbital s. It means that it is an element that belongs to a group A, yes, and the block S. When you have in your valence shell only an orbital s, it means that it belongs, ça appartient, it belongs to the block S, and it is a group A. For example, 2S1. 2S1, it means that it belongs to the block S, and because it belongs to the block S, it is a group 1. 2S1, you have only one electron, it belongs to the group 1A, and we call them the alkali metals, les alkanes, the alkali metals. If you have in your valence shell 2 or 3, for example 3S2 or 4S2, you have in your valence shell only S. Block S, it is a group A. All the elements that belong to the block S and P are groups A in French. All the elements that belong to the block D belongs to group B in French. Is it crystal clear?
Yes,
Okay.
miss.
Yes.
If you have an element with the orbital S, 4s2, for example, 4s2 within the valence shell, it means that it belongs to the block S, but S2, 2 electrons, it means that it belongs to what we call the group 2A, the alkaline earth metals.